So this is the application that we're going to create in this video tutorial. um, this is nothing but this is just a HTML canvas which has a black colored border, and inside the canvas we are drawing a circle, red colored circle, which is just bouncing around inside the canvas. And on the right hand side you can see some input controls. So you can like change the radius and initial position and initial velocity of the ball. Like I'll change it to 500, then I'll stop, and when I'll start the simulation again, it will be started with these set of initial conditions. So this lesson is aimed at helping you understand the basic physics behind the two-dimensional collisions and how to implement those basic concepts into your JavaScript code and create this basic simulation. So this lesson does have a few prerequisites. You'll need to have a basic knowledge about JavaScript. Like you do not need to be an experienced developer, but some basic knowledge about the functions, variables, if else, and arrays is required. And additionally, if you also have some familiarity with the document object model, that will also be helpful, but it's not necessary. In addition to that, you also need to be familiar with HTML canvas, like the basic stuff. You do not need to know everything about it, but if you know how to draw basic shapes like circles, how to draw lines and stuff, that'll be enough. And even if you do not know that already, it'll hardly take about 20 to 30 minutes. You can just right now find some material on the web and learn about it, and then come back to this video. So let's first get into the physics of the problem. So here is a simple graphic that demonstrates how collisions work in two dimensions. So let's consider this ball which is moving towards this direction. So it has an initial velocity vi, which is v initial, and like it has two components. Like in the x direction it has velocity vx, and in the y direction it has velocity vy. So the initial velocity is just a combination of these two components. This is the horizontal component and this is the vertical component, and now you can see it will travel along this path and it will collide at this point. And you can also notice that the wall is strictly vertical. So after the collision, let's assume the ball is in its final state, which is here, and it's moving towards this side now, and this is its final velocity. So now you can notice that in the final velocity the vertical component has not changed. It was earlier vy, and even after the collision it will be vy. This is in accordance with the principle of conservation of momentum. Since no force is acting in the y direction, so the speed of the ball in the y direction will not be changed. And for the x direction, when the ball and the wall collide, the interaction will occur in the horizontal direction. So the wall will exert a force on the ball which will be perpendicular to the wall. So as a result, the velocity along the x-axis will get changed, and it will get reversed actually in direction. The magnitude will not change because of the conservation of energy. So like the magnitude of the speed, like the speed along the x-axis will be the same initially and even after the collision. Like it was moving with this speed vx towards the wall, and it will continue to move with vx, but it will now recede from the wall after the collision. So the in a generalized case, the component of the velocity which is perpendicular to the wall will get reversed, while the component which is parallel to the wall will not be changed. So this is how our program will implement collisions. You can see the generalized case on this side. Whenever we even if the wall is not vertical, so what we'll do, will separate the velocity of the ball into two components, one which will be perpendicular to the wall and one which will be parallel to the wall. And after the collision, after the ball has collided, what we'll do, will just reverse the perpendicular component. We'll just reverse its sign, and the parallel component will be unchanged, and that will be the velocity of the ball after the collision. So it'll move in accordance with that now. So now it comes to detecting the collisions, when the collision are going to occur. So the collisions in our program can occur in 4 different positions: right hand side, left hand side, top and bottom. So these are basic equations to detect when the collisions are occurring. So the position of the ball is also in 2 components: the x coordinate and the y coordinate. So the ball will be touching the right hand side wall when the position x, the position is the position of the ball is actually the position of its center. So when the position x of the ball, the position x component of the position of the center of the ball added with the radius of the ball will give 500, that is the right handmost side of the canvas. This will be 500 into 500 canvas, I forgot to mention. So when the position x added to the radius will give 500, that means the ball is in this position. It can be in a different position in the y direction, but it'll be in the x direction, it'll be touching the right hand side ball. Similarly, when position x, which is this, the position of the center of the ball, subtracted by the radius gives 0, it'll be touching the left hand side wall. Similarly, these two equation, you can look at these two equations and understand how these relate to these positions. And for the case along the x direction, when position x plus r is less than 500 and position x minus r is greater than 0, that means the ball is not colliding with either left or right hand side, it's in between here. Similarly, you can check for the y direction. So this is how our program will check for collision, and if the collision is occurring, the corresponding component of the velocity will be reversed. So this is what we're going to start with. I already have an HTML document and it has this code inside of it. So this will be the basic HTML structure of our web page. So head and a body that contains a canvas and other stuff. So first of all, the canvas has dimensions 500 by 500 pixels, and it has a solid 4 pixel black border. We're obviously going to need the border in this application to be able to see the walls, and it has a float property set to left because it will exist on the left hand side, and I've inserted some margin, and it has ID, it goes by the ID box, and we'll use this in JavaScript. So the next element, division, it has the float property set to right, it will be in the right hand side, and I've changed the background color and I've added padding and margin. So inside the division we have some inputs. The first one is the radius, and it goes by the ID rad. It is of the type text, and the default value of it is 30. And similarly, the position and velocity, these come in 2 components. The position has the x component, which is default value 250. Similarly, the y component, which is default value 250. Notice the IDs of these elements. We're going to use these in the JavaScript code. Similarly, the velocity also has 2 components. I stands for x component, j stands for y component, and the default values are 200 and 300. And finally, we have a button which will be used to start and stop the application. By the default, it has start written over it, and the on click event does not have anything right now. We'll insert the code in here when we are writing JavaScript. So I've left it empty for now. So this is what our page will look like. So the empty canvas and a button and the input fields with default values, and right now this button will not do anything. So now let's move on to the JavaScript part of our code. So I'll add the script element right here inside the body, and let's start by defining the variables. First of all will be the context of the canvas. So first we'll get the canvas object. So the ID to the canvas was box. And now from this object we'll call in the another function called get context, and we'll pass the argument a string which contains 2D. So this returns a function this returns an object of the canvas, and that we call the function get context of that object, which will return another object which will be stored inside this ctx variable. So that context variable will be used to draw the stuff inside the canvas. So that is actually another object which is returned by this get context function. So the other variables will be used to store the position, velocity, and radius of the ball from these input fields. So we'll initially we'll keep them all undefined. So the position will have two components, so we'll define it as an array, a two-dimensional array. Initially we'll keep both of the values undefined. Similarly for velocity, we'll have vel variable, and it'll also have both of its components undefined, and we'll define another variable rad for the radius. So now when the button is clicked, this one we'll add in the on click field, we'll add a function start underscore stop. So this function will be called whenever this button is pressed. We'll define this function right here. So now when our button is pressed, so either our simulation has been started, or it is stopped, and we need a button to start it right now. So there can be two cases, so we need a variable to hold those two states. So we'll define a variable which will be a boolean variable started, which will initially be false because initially the simulation has not been started. So inside this function we'll check if the variable is true or false. If the started variable is true, then we'll add some code here, and if it is false, then we'll add the according code here. So let's see if the started variable is false. That means the game has not been started, the simulation has not been started yet. So then we know that the user has entered some fresh variables, and we need to fresh values inside the input fields, and we need to apply them to these variables. So for that we'll add some code which will look something like this. So firstly, the first element of the position array will have the x component of the position, which will get from position underscore x field, and initially these calls will return strings. The value stored inside the text input field will be returned as strings. So we need to use this number function to cast them to numbers. So now we've converted them to numbers, and that will be stored inside these variables. So position x, position y, the second component, similarly both the components of velocity and then the radius. So after that, when we have done this, now the button will become a stop button. Now the button should be used to stop the simulation. So for that we need to change the content of the button. So we'll do that by document.getElement by id, and the id for the button was start stop button. Now value will be equal to stop now, because now this button will be used as a stop button. Now we'll start the simulation, that is, we'll start some sort of loop. So I'll add the code later on. Here I'm just leaving a comment for now. So now let's see what we'll do if the game has if the simulation has already been started and now we need to stop it. So first thing we'll do is that we'll stop this animation loop. And the second thing we need to do is change the content of the button to a start button now. And after these conditions has been executed, we now need to change the started boolean as well. So if the game let's go through the logic first of all. So this function will be called if the game has been started, it will be stopped, and after that this started variable will become false because it was initially true. And if the case was on the other hand, like if the started variable was false, then this stuff will happen, and now the started variable will become true because the game will be started now. So at the end of these conditions we'll add started will reverse its value. So that's how it's done. This statement just reverses the content of this variable. So if the variable is initially contained true, then it will become false, and if it was initially false, it will become true. So now let's look at these loops. So if you've previously done animations, you'll know about a function called setInterval. So this function takes two arguments. The first one is a pointer to a function, and the second one is an integer, which is time, which actually denotes time. So this function f will be called after this much milliseconds. This time is in milliseconds. So we need to call a function repeatedly so that our stuff can be drawn on our screen. Repeated frames that will draw the multiple frames, and like the animation effect will be created. So first of all we need to create that function. So we'll call this function draw and update. This function will first of all draw the ball, and it will also update the position of the ball according to the velocity of the ball. So for now we'll leave it empty. First we'll deal with this interval. So the function draw and update will be called. Remember not to put the brackets here, because this is a pointer to a function. We do not need to call the function here, we just need to point to the function. And the time will be 1000 by 60 milliseconds. We know 1000 milliseconds means 1 second, so 1000 by 60 means this function will be called 60 times in 1 second. So that will give a frame rate of 60 hertz. So that's 60 frames per second, and that's pretty acceptable for all the machines. So the loop has been started and this function is being called repeatedly now. But when we need to stop the simulation, we need to stop calling this function. So for that we need to call another function, which is clear interval. So this stops an interval that is already being called. So for that we need to stop this interval. So right now there is no way for this function to be knowing that which interval we need to stop. So for that this interval needs to have an ID. So this actually the setInterval function, when called, returns an integer or another sort of some value which can be stored by you in some certain variables, and that can and the same variable can be used to stop the interval. So we'll define a variable I_id, which is interval ID. So we'll set interval underscore ID equal to the value returned by this function. So that will return the ID of this interval, this interval. So when we clear the interval, we now can specify this ID, and it will know which interval to clear. So that's this interval which was set right here. So that's how we stop this interval. And now we'll work on the function draw and update. So first things first, we will use this ctx variable, the one which we assigned its value right here, and we'll set the fill style to red. We'll draw the ball in red color. The next thing we'll do is we'll clear the screen. So for that, like we'll clear the previous frame, so the canvas already has the ball drawn over it, so we'll clear that and we'll draw the ball at the new position in each updated frame. So that's clear rectangle. This function is used to clear the canvas, and we need to specify a rectangle using a set of 4 variables. So that's how it's done. The first two the first two arguments is specify a point, and the next two arguments also specify the width and height. So from this point, this width and this height specify a rectangle, so that rectangle will be cleared. So this is used to clear all of the screen because it's from the origin to the width and height of the canvas. So after we have cleared the canvas, we need to draw the ball. We'll use these function calls to draw the ball. So first of all, ctx.beginPath resets any changes that have been made to the path variables and stuff. So we'll begin the path, and now the second function call describes the structure of the ball. So the arc function actually describes a path which is in shape of an arc. So the first two arguments are the center of the arc, so that's position of the ball, because position is denoted by the center of the ball. And then the third argument is the radius of the arc. The fourth and fifth arguments are the initial and final angle of the arc. So initial angle is 0 and the final angle is 2 pi, which equals in degrees, it equals to 360 degrees. So from 0 to 360 degrees we describe an arc of radius this centered at this position. So this you can see that it's a circle. So now we have described the arc. It will not appear on the screen right now. When we use the ctx.fill method, it fills all of the shapes which have been described before it. So now the ball has been drawn after we have called ctx.fill method. Now after this, we need to implement the logic for collision and for the updation of updating of the position. So the position will be updated in accordance with the velocity. So the position, I'll write here, the x component of position will be incremented by x component of velocity divided by 60. So let's see how it works. So I like to see the velocity input as having the inputs pixels per second. So by the formula for speed and distance, we know that distance traveled is speed multiplied by time. So the speed is this much and time is 1/60th of a second. So that's velocity multiplied by 1 by 60, because the frames are being updated every 1/60th of a second. So this much distance will have been traveled by the ball along the x-axis. And for the y-axis, we need to do the similar thing for position first component, so that y component of the position will be incremented by this amount. Now we also need to perform collision. So the logic for the collision I've already explained to you, so I'll just write the code here. So this is the code that will implement the collision. So I've already explained to you. So the first if block, if the position plus the radius is greater than or equal to 500, I'm not only using equal to, I'm also using greater than, because if it is equal to 500 or it has gone further to the right side, or the position minus radius is equal to 0 or it is less than 0, that means if it is at the left edge or it has gone beyond the left edge. So for one of these two cases, the velocity, the x component of the velocity will be reversed. Similarly, you can check what happens for the y coordinate. So I think that was it. If there are no errors, this should work fine. So I've saved it and now I'll start it. So you can see this is working completely fine. So if you enjoyed the lesson, please leave a like and subscribe. And the next video, which will show you how to implement the collision among balls, like when one ball collides with another, will be up soon. So if it has already been uploaded, the link will be down in the description.